Today we are going to introduce CRC hardware implementation. CRC, or Cyclic Redundancy Check, is an error detecting code. It finds changes in data as it travels from one computer to another by adding a code to the end of the data stream. The sending computer creates the code and the receiving checks it. If the codes check out, the data is accurate. If the codes don't check out, the data is corrupt. Let's look at the picture. Paper and pencil design included augmented data word, divisor, and remainder. Divisor have n-k plus 1 bits. Here n means the length of code word, and k means the length of data word. Divisor is based on the leftmost bit. When the leftmost piece is 0, the divisor is 000. When the leftmost piece is 1, the divisor is 011. Remainder have n-k bits. These are some steps of calculating remainder. First, we assume that the remainder is originally all zeros. Second, at each time click, we repeat the following two actions. Use the leftmost bit to make divisor and the next bit from the augmented data word. In our example, we regard the arithmetic process as the conveyor belt, and augmented data word as the message. Because our conveyor belt can only hold 3 numbers, we need to add 3 zeros to the end of our message. These are placeholders for the final code. The registers start with all zeros. As our message enters our conveyor belt, we XOR each pair of numbers and enter the corresponding 1 or 0. As a number falls off the end, we XOR its value to the incoming number. Let's see this in action, starting with the last bit at the end as it goes into the feedback for the XOR operation. In time 1, the feedback 0 and the green 0 are XORed together, resulting in a 0 in the last bit. The blue 0 is also XORed with the feedback 0, which results in a 0 in the left box. Finally, the feedback 0 is XORed with the incoming 1, which results in a 1 in the last bit. We continue this process of shoving our message down the register conveyor belt until we reach the end. This is time 2. The leftmost bit is 02, so the divisor is 000, just like time 1. Time 3. We can see in time 4, the leftmost piece is 1, so the divisor is 011. After calculations, we can see the result of time 5. Time 6. And time 7. Finally, we get the remainder 110. Then we know 1001110 is our code word. The receiving computer runs the complete message through its feedback register. If the check produces all zeros, the data is accurate. We use the same concept here, and finally get the remainder 000 successfully. This is the content of our report. Thank you for watching.